Good morning. Today we are discussing the proportioning of concrete. It's the determination of proportion of concrete ingredients such as cement, fine aggregate, coarse aggregate, and water admixtures is called proportioning of concrete mix. The proportioning of concrete mix is depends upon the properties like workability, strength, permeability, and durability of the concrete. This is specified in page 22, cross 9.1, 9.11. Concrete mix proportion. There are two types of concrete mix proportion: nominal mix and the design mix. The nominal mix is the fixed mix proportion. Is available for various grades of concrete. It's like M30, M10, M15, and M20. M10 1:3:6, M15 1:2:4, and M20 1:1:3. This is mentioned in the IS 456. This nominal mix is used only for the grade below M20. If the grade above M20, we have to use design mix. The nominal mix concrete will use M20 or lower. Then design mix. In design mix, depends upon our requirements, like the target strength or the final target strength after hardening, or the fresh concrete properties like water cement ratio, workability, etc. to fix the mix design, and it is based on the IS 10262 2009 and IS 450 2000. This type of mix proportion, design mix proportion, is suitable for higher grade concrete. While preparing the mix proportions, some important points are noted. It is mentioned in the IS 456. Information required. Clause 9.12. This type of mix. This type of design mix or normal mix. Then grade of designation, M20, M25, M30, etc. Type of cement, 43 grade or 53 grade, or which type of cement is used, and maximum normal size of aggregate 20 mm or above 20 mm or below 20 mm. That's normal size using. Size is mentioned. The minimum cement content depends upon the environmental condition and depends upon type and mix. We have to fix the minimum cement content. The maximum water cement ratio depends upon the workability. We can fix the maximum water cement ratio, and the workability and the mix proportion. Nominal mix concrete, this mix proportion for exposure conditions. This table 4 and 5 gives the exposure condition in page 18 and 20 IS 456. It's based on the exposure conditions. If it is exposed to normal atmosphere, or it is exposed to sea, or it is exposed underwater condition, or saline water condition, alkaline water condition, alkaline ground, etc. Depends upon the environmental conditions. The mixed proportions are varying. So mention the exposure conditions and the temperature of the concrete facing. The high temperature, the more evaporation. So depends upon the evaporation loss of the water. We need to fix the maximum water ratio and workability. So depends upon the temperature condition also. The mix is varying. So we have to mention the temperature condition and method of placing and degree of supervision. If yes, there is good supervision, then they have to follow all the strict rules, so we get the more strength. Then after proportioning, we have to batching the concrete. Batching the concrete means measuring the ingredients of the concave. The batching may be two methods, volume batching and wave batching. Batching with good quality of the concave. The volume batching, in volume batching, materials are measured on basis of volume. This is less precise than wave batching. Aggregates or ingredients are measured in the box. It's known as a gauge box or measurement box are prepared, and one bag of cement contains 50 kg is equal to 35 liters of liters. So the gauge box or measurement box are prepared based on the 35 liters or multiples of 35. And water is also measured by volume. For example, 1:1:2 ratio. 1 bar cement to 1 bar sand, 2 part aggregate. So 1 bar means 1 bar, we are taking 1 bag cement. So 1 bag cement 35 liter. Then this gauge box is 35 liter. Then sand is taken 1 gauge box and aggregate is taken 2 gauge box. This is 70 liter. Then next is weight batching. This weight batching is more accurate than the volume batching. It is based on the weight of the ingredients. It can be measured by using weighing equipments. There are two types of weighing equipments, mechanical weighing equipments and electronics weighing equipments. The cement, finer gauge, coarser gauge and water are taken by weight. After measuring the ingredients, then mixing. The mixing can be done by two methods based on our quality and quantity of the concave. The normal mass concave and a good quality of concave is required. Machine or mechanical mixer is used. The main purpose of mixing is to get the finally obtain a uniform mixer, and the uniform mixer means the color is uniform and the consistency of concrete also uniform. The concrete is next is pricing of concrete. The concrete should be priced before the initial setting time. That is, for an ordinary Portland cement, 30 minutes is the initial setting time. Before 30 minutes, you have to price the concrete in final position and compact it well, and leaving the concrete without disturbance. The placement of concrete is very important operation. Then after pricing, you have to compact the concrete. The compaction is the process of expel the entrap layer from the fresh concrete and get a densely packed concrete. It enhances the good bond between aggregate and reinforcement. It also increase the abrasion resistance and durability of the concrete. Decrease the permeability and minimize the shrinkage and creep characteristics. The compaction can be done by hand or machine compactions. The curing of concrete, next process. The curing is the process of maintaining the moisture content and temperature of the concrete during the hydration. During the hydration process, water is reacted with the cement and heat generated. This is a exothermal reaction, heat generated, and so the temperature of the concrete increases, and due to the increase in temperature, the water is evaporated from the surface and into the concrete. So, in order to prevent the loss of moisture content and the increase in temperature, you have to maintain this moisture content and temperature constant to apply the curing. The curing can be done by ponding method or sprinkling or wet covering. And this curing improves the plastic shrinkage of concrete. It prevents the plastic shrinkage of the concrete. And due to the hydration process, the concrete temperature increases, so the process of water for the hydration can be raised on this. And curing also helps the hardened and concave, and between the bond between the internal materials like aggregate and cement. It also prevents the damage or the bondage between the concrete and reinforcements. It helps to get an impermeable concrete and crack-free concrete and durable concrete. Next is stress strain curve. The figure shows the stress strain curve of the concrete. Initially, it is linear. Linear means it's straight line. So the stress is proportional to strain up to an elastic limit. That is obeys Hooke's law. Within elastic limits, stress is proportional to strain. So it is linear. And after that, let's say get a peak value, and after the elastic limit, it is give more. The stress strain curve is almost horizontal. So the maximum strain is for the concrete is taken as 0.002 to 0.003. So this shows the stress strain curve, and the peak values between 0.002 and 0.003. It depends upon the higher grade of the concrete. This stress strain curve is specified in IS 456. Initially it is linear up to elastic limit, and there is a parabolic shape, and the parabolic shape is up to 0.002 strain, then up to 0.0035 is horizontal. Maximum strain in the concrete is taken as 0.0035. So this is the stress strain curve. Initially is a parabolic and a horizontal. This is given in IS 456.